Pop quiz. Which set puts the hydroxy on the less substituted carbon and adds to the same face? A. Acid with water. B. Hydroboration, then oxidation. Or C. Oxymercuration, then demercuration. The correct answer is B. Products of hydroboration oxidation are anti-Markovnikov and have a syn stereochemistry. So hydroxyl goes to the less substituted carbon on the same face. Let's find out why. In this video, you will learn the main ways to convert an alkene into an alcohol, how regiochemistry and stereochemistry differ among them, and how to avoid common traps like rearrangements. The big idea is simple. We add a hydrogen and a hydroxy across a double bond. Two questions drive the outcome. First, which carbon gets the hydroxy? Markovnikov or anti-Markovnikov? Second, do the new groups land on the same face, called syn, or on opposite faces, called anti? The simplest path is acid-catalyzed hydration. Protonate the double bond to make a carbocation. Water attacks, then deprotonate. It gives the Markovnikov alcohol but offers little stereochemical control, and carbocation rearrangements can scramble the position. Following the mechanism above, propene under acid and water gives isopropyl alcohol. On many substrates, rearrangements can occur, so the carbon that ends up as the alcohol may shift if a more stable carbocation is available. Let's fix a common misconception. Syn or anti describes how the newly added hydrogen and hydroxy relate to each other, not how they relate to groups that were already on the molecule. So far, we've discussed that acid hydration gives the Markovnikov alcohol, may rearrange, and does not control the new stereochemistry. Curious how much you're remembering? Your personalized practice test, flashcard set, and study guide are all waiting for you. Just tap the link now and keep watching. Future you will thank you. Now, let's move on to hydroboration, followed by oxidation. First, borane delivers hydrogen and boron to the same face, favoring the less substituted carbon. Then, oxidation replaces boron with a hydroxy. The result is an anti-Markovnikov alcohol with syn addition of hydrogen and hydroxy. For 1-methylcyclopentene, hydroboration followed by oxidation yields 2-methylcyclopentanol. Hydrogen and hydroxy arrive on the same face. The hydroxy ends up on the less substituted carbon of the double bond. Oxymercuration, then demercuration, also hydrates alkenes. The reaction gives the Markovnikov alcohol without forming a free carbocation, so rearrangements are suppressed. But the first step is anti-opening of a mercurinium ion. After the second step, the product is the Markovnikov alcohol. Let's compare the three. Based on regiochemistry, acid hydration and oxymercuration give Markovnikov, while hydroboration gives anti-Markovnikov. Looking at stereochemistry, acid is variable. Oxymercuration delivers anti-placement without the rearrangement risk, while hydroboration is syn. Now, let's turn an alkene into a diol. Start with a double bond. If we use osmium tetroxide or cold, dilute permanganate. Both oxygens add to the same side. That gives a syn 1,2 diol. But if we go the epoxide route, we first oxidize the alkene to an epoxide, then open that ring with water in acid. The nucleophile attacks from the backside, so the two hydroxyls end up on opposite sides, an anti-1,2 diol. Same goal, 2OHS, different path, different stereochemistry. To recap, alcohols are prepared from alkenes by acid-catalyzed hydration, hydroboration oxidation, and oxymercuration demercuration, each with unique regiochemistry and stereochemistry. For diols, syn addition is achieved with osmium tetroxide or permanganate, while anti-addition is achieved via epoxidation, with peroxides followed by hydrolysis. Now that you've watched the video, let's see how much you remember. Head to the link in the description where you'll find Quizlet content made just for you.